Fast forward 5 seconds.
Hey Ben, if you watch this, you're an idiot for forgetting.
Benjamin Schultz.
I got to delete the video.
Oh,
Benjamin baby.
You can't even take that off the record.
well, I can't.
Well, you could just since you haven't
So
started
we're
the
gonna
lesson,
talk
you could
about-
stop it. Sorry.
Differential equations, and you kind of solved some yesterday, right? But I'm gonna remind you the strategy that we know to solve differential equations when they involve x and y. And we're also gonna talk about exponential growth and decay and how that relates to differential equations. Okay, so when we have a differential equation that involves both an x and a y, if it is possible to separate them, that is the strategy that we need to remember from last year. So please write down dy dx equals x squared over y squared. Yeah. We're kind of smushing two together. Okay. So if this is my differential equation, first of all, let's work on the general solution. So I want my y's with the dy and my x's with the dx. So I'm going to take y squared and multiply it over. And then I'm going to take x squared and keep it, but then multiply the dx over. Once you have separated your variables, we can integrate both sides. Quick! Antiderivative of y squared.
1/3, yeah.
Technically 1/3 y cubed plus c, but we'll just put the plus c together with this plus c and call it good. Okay. Also, we want to solve for y, so we're going to write y cubed equals x cubed plus 3 times c, which is still a constant. C isn't like a hard and fast as a c. C means constant, so we're just going to keep it as constant until we actually solve. So our general solution would be y equals the cubed root of x cubed plus c. Now I will remind you, but if we were to have, if this were a square root, we would have to include the plus or minus. Okay. Now, if I ask you for a particular solution, that means I'm giving you some sort of coordinate. So let's just take this coordinate right here, the coordinate 0, 2.
Richard thinks you spelled particular.
My arm.
You said particular.
Remember. Okay.
You're famous.
On the record.
So all we have to do is throw these values in to solve for C. Caleb,
Huh?
let's see.
8.
This is a good Friday lesson. Okay, thoughts? This is very straightforward. Okay. write down dy dx equals x squared y. Here's where we're gonna have some fun. Okay. If we separate variables, what does that look like, Benjamin?
Does it look like y? Wait, separating variables. My brain's having a moment here. Sorry.
Y is over here, x is over here.
Yeah. Okay. So if dy dx equals x squared y, then does that mean you could do dy dx divided by x squared equals 1? Or
Well, we want like y with dy and x with dx.
oh, okay. That's so.
So how do I get y over here?
Could you divide it by y?
Okay, so 1 over y dy equals x squared stays, and we can multiply that dx over. How's that?
That's what I was thinking too.
Yeah. Okay, so when we integrate both sides, what do we get on the left?
Then look at the absolute value of y.
Yeah. Way to go, Chris.
Okay, how do we solve for y?
Put both sides
E. Good old Euler coming to save the day again.
Mm-hmm.
But remember that this is the same thing as e to the 1/3 x cubed times e to the c, which we can write as, what's e to the c? Still a constant. So we can write this as c e to the 1/3 x cubed. That's what I wanted to talk about. We're gonna get there in like 10 minutes. Don't you worry, I've got your minutes. Okay. Which one did I want? Okay, so this is what we call our general solution. If we want our particular
I see what you did there.
for the coordinate 0, 1, you solve that for me.
Everyone was looking like, why am I the only one getting called out for this?
Okay, do you agree? Let's see his one. Okay,
But no, I'm the one that gets called out because everyone hates Chris. They made a TV show about it.
that is exactly what it is, everyone.
Hey, they made a TV show about it. It must be true.
What I would like you to do
Everyone
is I would like you to solve
everyone
A,
hates Chris.
and then
I
B,
immediately got that.
and then
That's
stop.
why. Okay. I need to move a little closer. Wait. I can actually can you read?
How many are we supposed to do again? Honey. Stop. I got 1/2. I did numbers. It says x equals 1. That's all you have. Oh.
Number three, the whole problem.
I can't see that much.
Absolutely not. Alright. We can remove the line as long as this doesn't pick that up.
We're in the zone.
Okay, 4.1
Not intense.
or 41 tenths, whatever you want. Okay, now, when we solve this separable differential equation, we can take 2y to live with dy, and we can keep 3x squared plus 1, but move dx over. This is nice. Antiderivative of 2y.
Y
Very good.
squared.
It's y squared. And over here,
X cubed.
x cubed plus x plus c. We need to have a conversation right now.
Plus or minus.
So our general solution, y equals plus or minus the square root of x cubed plus x plus c. Now, our particular solution is f of 1, well, our initial condition is f of 1 equals 4. So it's the positive 1. If this were f of 1 equals negative 4, we would choose the negative 1, but we have to choose one or the other. Since our y is positive, we have to choose the positive y.
Wait, how do we know the y is positive?
Because 4 is positive.
Oh, right.
Yep.
Okay. I was just making sure that's where we had to look.
14?
Yeah, I got a question.
What?
I have a question. I got the right answer, but I don't know if I did it right.
For what?
Well, I got the right answer for C, but what I did instead was I just plugged it in up here instead of simplifying, like doing the square root.
Okay, so yeah, that's fine.
Well, I did this afterwards, but here when I plugged down C,
No, that's fine. Just since it's a particular solution, we have to choose the positive one.
okay,
And your C is still the same as mine.
yeah, but
Make sure the square root extends. Thank you, Richard.
they're bullying you, but I would never do that.
Okay. He's trademarked too. We're on the same page? Okay, so Benjamin plugged in the values right here to solve for C. I have no problem with that. Okay, just make sure you keep in mind the plus or
For the people at home, where was that?
What?
Where was
minus. Right there.
Oh, right.
Because how are the people watching?
The people watching are gonna be us first.
Wait,
Who's that?
Zane. You better win, Zane, whatever
No.
you're doing.
No.
Okay. Here's what you guys are talking about. So, for exponential growth functions, and exponential decay, quantities will grow and decrease by a factor or a percentage that are exponential. And what we can say, the rate of change of a quantity is directly proportional to the quantity itself. What does it mean? The rate of change, derivative, dy dt, because we do time, is directly proportional to the quantity itself. Directly proportional means that it's multiplied by some constant. The quantity itself, we're talking about y. Okay? So when you see this, we know it means this. Okay? And since we're so slick with our mathematics, we actually know what's going to happen. Yes.
Y equals C times E to the K.
P equals E to the RT. It's per. I'm just saying it's per.
It's not per.
It's
Per is A equals P.
Oh,
E
it's
is
A
R.
equals.
Good
I forgot
try.
the A.
This is a close one.
So it's A per. Okay.
I like that, yeah.
Let's just talk about the separable differential equations. Okay? This is what we have when we separate. We get the natural log of absolute value of y equals kt plus c. Good old Euler comes to our rescue again. Y equals c e to the kt. So guess what? This is now the second time you've done this calculus. When you see the words, the rate of change of a quantity is directly proportional to the quantity itself, boom, y equals c to the kt. You don't have to do it again. What does c stand for?
Original. Like the original stuff that you had.
Okay, c is the constant, yes. But in relation to this exponential problem, it is the initial amount.
So like, why in algebra 2 class did we learn it as per then?
Because we only used it in relation to money.
Ah.
We're here, we're working with like bacteria and stuff.
Bacteria is fun.
Sure.
Hi, Zane. Yeah.
See, look at all this fun we're gonna have with bacteria.
Okay. So bacteria in a culture increased from 400 to 1600 in 3 hours. Just in case you wanted to write it down, I was giving you time.
Oh.
Okay. Find an appropriate model. Okay. Well, do we know the initial amount?
Yep.
What's the initial amount?
400.
So then K is actually going to be your rate. It's always going to be a decimal. If we're increasing, it's positive. If we're decreasing, it's negative. In this case, our rate should be what kind of percentage? Positive?
Yeah.
Thank you. Okay, so we know that we have 1,600 bacterias after a time of 3 hours. Please find me K. With your calculator.
I was gonna do it in my head.
You were going to try to. But it wasn't going to be successful.
I don't think Benjamin was gonna try to do that. assuming that Benjamin.
It's nice to be overestimated.
Should probably, oh, my calculator. Nope. No.
Positive, so that's good.
That sure is a positive.
Oh, 4. That's all 4.
Three. But 3 being like 5
That's what I heard come out of someone's mouth.
0.462.
Give me more than that.
0.9811204. Well, I thought we were around a 3, okay?
Okay, so what I would do, I know that you're used to rounding to 3, and Caleb, that is what I want. However, since this is a rate, a very small number, that we're gonna use in our equation for something else, let's double that and round it to 6.
Okay.
So now, we have y equals 400 e to 0.462098 t. So if I ask you, find the number of bacteria at the end of 6 hours, we could plug 6 in for t and find that. How many do we get? Yes.
6,400 bacteria.
That's exactly that. That was very interesting.
Well, yeah, because it's the natural log of 4 over 3 times 6. So you have the natural log of 4. And then the e's cancel all out. Okay, I'm gonna look at one more example so you're not freaked out by the algebra. And then I'm gonna be done talking. Okay. Our half-life is 1590 years. And even if we didn't know this right here, even if we didn't know that, we would know, well, first of all, y equals c e to the kt, right? We know that 1/2 equals e to the k times 1590. Talk me through, what did I do?
Magic.
So, right. So whatever I start with, I have half of it.
Yeah.
So when I divide c over, it is 1/2. And then t is the time, how long it takes to get there. Okay. Now, lucky for us, what do we know?
We know 100.
We know 100, but we wouldn't have to find k at least. So k is our equation is y equals 100 e to the negative point
0, 0, 0, 4, 3, 6.
can all hear you.
You need to work on your whispering.
You know what I'm talking about? Or like when Siri says something to you.
Now, I want you to look at B. C. C. Look at C. When will the mass be reduced to 30 milligrams? Where do we plug in 30?
Why?
Okay, good. I don't have to worry about